Hi students, in exercise 2.2 the polynomial lesson. In the exercise 2.2 first main we are going to discuss about the second problem. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and their coefficient. Here the quadratic equation is 4s square minus 4s plus 1 is equals to 0. First step, you have to find the roots or zeros of the polynomial, and in the next step you have to verify the relationship between the zeros and their coefficients. Okay, firstly we'll find the zeros of the quadratic equation by splitting the middle term, that is minus 4s. We have to split into two terms. That the steps are: first you have to multiply this 4 with 1. 4 ones are 4. You have to find two factors of 4 in such a way that the product of that two factors the product of the two factors should be 4, and when you add or subtract, that should be minus 4. So the factors of 4 are 2 2s are 4. So 2 2s are 4, plus into plus is plus. So all the conditions of product is satisfied. Now we have to check for the, when you add or subtract these two numbers, you should get minus 4. That will be 2 and 2 plus 2 is 4, but we should get minus. So that's why I'll put minus and minus. So minus into minus is plus. We have to add minus 2 if add, you'll get 4, and the greater number sign, both are equal numbers. That's why you will put minus. So all the conditions are satisfied. Now I'll split the middle term, that is 4s square minus 4s, you will write it as minus 2s, and minus 2s plus 1, which is equals to 0. Now you have to group two terms together, and you have to take the common term out. So here 4s square and 2s, you can take 2s as a common. If you take 2s as a common, here 2 2s are 4, you took 2 as common, one more 2 will be remaining, and s square, you took s as common, one more s will be remaining, that will be 2s, minus here you took 2s as common, so here you will be having 1. Here 2 in the next term, 2s plus 1, you don't have anything common, that's why I'll write it as minus 1 as a common. So you will write my 2s plus into minus is minus 1, which is equals to 0. Okay. So now this 2s minus 1 and this 2s minus 1 is common, that you will take it out. 2s minus 1 as a common. When you take 2s minus 1 as a common, here 2s will be remaining, and in this term 1 will be remaining, which is equals to 0. Now a product of any two numbers is 0, means any one of the term will be 0. That's why you will write 2s minus 1 is equals to 0, or 2s minus 1 is equals to 0. Here 2s is equals to 1, or 2s is equals to 1. So s will be 1 divided by 2, or s is equals to 1 divided by 2. For this quadratic equation, you got two equal roots. So now you got 0 of the polynomial, and now you have to check this 0 with the coefficient. That is, you will take one root as alpha and one of the 0 as beta. So alpha plus beta is equals to minus b by a, which is equals to alpha is 1 by 2 plus beta is 1 by 2. For minus, you will write minus. B is nothing but it is a coefficient of s, that is minus 4 divided by a is coefficient of s square, 4, which is equals to half plus half is 1, minus into minus is plus, 4 by 4, 4 and 4 get cancelled, 4 ones are 4 ones are, which is equals to 1, 1 is equals to 1. So this is verified. Second one is alpha beta, that is product of two zeros of the polynomial alpha beta. Alpha is 1 by 2, which is equals to c by a. Alpha is 1 by 2 into beta is 1 by 2, which is equals to c. C is nothing but it is a constant term, that is 1, divided by a is coefficient of s square, that is 4. Here you have to multiply this, 1 ones are 1, 2 twos are 4, which is equals to 1 by 4. So you got LHS is equals to RHS. That's why it is verified. Firstly, we found the zero of the quadratic polynomial, and we verified the relationship between the zero and their coefficient. Relationship between the zero and their coefficient. Thank you.